So this is part 2 of the video series on problems on standard identities. And here we have a problem that says use a suitable identity to get each of the following products. X plus 3 multiplied by x plus 3. Now x plus 3 multiplied by x plus 3 can be written as x plus 3 whole squared. Now if you look at this particular expression, it is actually similar to a plus b whole squared, and that is equal to a squared plus b squared plus 2ab, right? Or we can say a squared plus 2ab plus b squared. Doesn't matter whether you use this one or this one. Okay, this is the standard identity 1. Standard identity 1. Now here, if you relate to this standard identity 1, let's call it identity 1. This is x is a and 3 is b. It means x squared plus 2, a means x, multiplied by b means 3, plus 3 squared. This is x squared plus 6x plus 9. In the second problem, we have 2y plus 5 multiplied by 2y plus 5. Again, it's exactly same to what we have done here. That is standard identity 1. This can be written as 2y plus 5 whole squared. It means that it should remind you of a plus b whole squared. A is 2y, b is 5, therefore 2y whole squared plus 2 multiplied by 2y multiplied by 5, that is b, plus b squared means 5 squared. So this is 4y squared plus 2 times 2 is 4 times 5 is 20y plus 25. This is your answer. This is 2a minus 7 multiplied by 2a minus 7. Now this can be written as 2a minus 7 whole squared. Now this should remind you of the standard identity 2. That is a minus b whole squared is equal to a squared minus 2ab plus b squared. Right? This is second identity. So here a is 2a and b is 7. So 2a squared minus 2 multiplied by 2a multiplied by 7, then plus 7 squared. This is 4a squared, then minus 2 times 2 is 4 times 7 is 28a and plus 49. This is 3a minus 1 by 2 multiplied by 3a minus 1 by 2. Now this can be written as 3a minus 1 by 2 whole squared. Now this should remind you of a minus b whole squared. That is standard identity 2, and this is equal to a squared minus 2ab plus b squared, exactly to what we have discussed here. So here a is actually 3a and b is actually 1 by 2, therefore this becomes 3a squared minus 2 multiplied by 3a multiplied by 1 by 2, then plus 1 by 2 whole squared. This is 3a multiplied by 3a, that is 9a squared, then minus 2 multiplied by 3 is 6, and 6 multiplied by 1 by 2 is 3, right? 6 multiplied by 1 by 2 is actually 3. So this is 3, and then you have a, this is plus 1 by 2 whole squared means 1 by 4. Here you have 1.1 m minus 0.4, then multiplied by 1.1 m plus 0.4. Now this can be written as, just rearrange it. So 1.1 m plus 0.4 multiplied by 1.1 m minus 0.4, right? This is commutative property of multiplication, that is a multiplied by b is equal to b multiplied by a. Now if you are thinking what's the benefit of rearranging it, then this should remind you of the standard identity 3, that is a plus b multiplied by a minus b is equal to a squared minus b squared. Now here a is 1.1 m and b is 0.4. It means that this will be 1.1 m whole squared minus b squared means 0.4 whole squared, right? Now 1.1 means what? 1.1 multiplied by 1.1. So first you multiply 11 multiplied by 11. 11 multiplied by 11 is 121. Now after this decimal you have one digit. After this decimal you have one digit. Therefore 1, 2. This is 1.21 m squared minus 0.4 multiplied by 0.4. So 4 multiplied by 4 is 16, and after the decimal you have one digit, here you have one digit, so 0.16. So 0.16, this is the answer. This is a squared plus b squared, and then within bracket this is minus a squared b squared. So let's rearrange it and write it as b squared plus a squared, right? That is commutative property of addition that says a plus b is equal to b plus a, right? Then multiplied by b squared minus a squared. Any problem? Same thing. That is a plus b is equal to b minus a. Now this should remind you of exactly the same identity what we have discussed here, that is identity 3. How? Identity 3 is a plus b multiplied by a minus b. This should be equal to a squared minus b squared. Now if you look here, your b squared will become a in this case, and your a squared will become b in this case. Don't get confused by this b and this a and this a and this b. Don't get confused. What you have to remember is you always have to correlate it with the standard identity. Doesn't matter whether here it could be x squared, y squared, and so on and so forth. Just you have to look at the pattern, and then you have to decide which standard identity we can use here. So in this case, this is actually a plus b. And same thing here, you have a minus b. B squared plus a squared multiplied by b squared minus a squared. That is a plus b multiplied by a minus b. Now this is equal to a squared minus b squared. So if this is a, then what will be a squared? A squared will be b squared whole squared, right? Then minus, then you have b squared. So b squared means a squared whole square. Okay, now this is b squared multiplied by b squared raised to power of 2, and we know that we always do it in this way: 2 multiplied by 2 minus a 2 multiplied by 2. That is b raised to power of 4 minus a raised to power of 4. Okay. Now you have 6x minus 7, and then you have 6x plus 7. Exactly the same what we have done earlier. That is standard identity 3. How? This can be written as 6x plus 7, and then this is 6x minus 7. Commutative property of multiplication, that is a multiplied by b is equal to b multiplied by a, and by rearranging it you can see here it is actually of the form a plus b multiplied by a minus b. A plus b multiplied by a minus b. the standard identity 3. So this is equal to a squared minus b squared. It means that this is 6x whole squared and minus 7 squared. This gives you 36x squared, and this is minus 49. This is minus a plus c, and this is minus a plus c. So basically this can be written as minus a plus c whole square, minus a plus c multiplied by minus a plus b, a plus c. This is same, these two binomials are exactly the same, so this is whole square. Now this is of the form, if you look at this properly, then this is actually a and this is actually b, and it is of the form a plus b whole square, that is equal to a squared plus 2ab plus b squared. That is standard identity 1. Now if you apply this here, you'll get minus a whole squared plus 2 minus a multiplied by c plus c squared. This gives you a squared, this gives you minus 2ac, and this is plus c squared. In this case, you have x by 2 plus 3y by 4 multiplied by x by 2 plus 3y by 4. If you look at this binomial and if you look at this binomial, exactly the same. Therefore, this can be written as x by 2 plus 3y by 4 whole squared. This should remind you of the form a plus b whole squared, that is equal to a squared plus 2ab plus b squared. And here this becomes a and this becomes b. So a squared means x by 2 whole squared plus 2 multiplied by a means x by 2 multiplied by b means 3y by 4, and then you have 3y by 4 whole squared, 3y by 4 whole squared. Now this is x by 2 whole squared means numerator x by x, so x squared divided by denominator 2 multiplied by 2, that is 4, then plus here it is 2, so this gets cancelled, and here you have, then in the numerator you have x multiplied by 3y, so 3xy divided by this 4, right? Then plus this is 3y by 4, 3y by 4 multiplied by 3y by 4. So multiply the numerators together. This is x squared by 4 plus 3xy by 4. If you multiply the numerator together, this is 9y squared divided by 60. This is your answer. This is the last one. This is 7a minus 9b multiplied by 7a minus 9b. If you look at this binomial and if you look at this binomial, these are exactly the same. Therefore, this can be written as 7a minus 9b whole square. Same binomial are being multiplied to each other. So this becomes of the form a minus b whole square. That is a squared minus 2ab plus b squared, right? So here your a becomes what? 7a, and b becomes what? 9b. So a squared is what? 7a squared minus 2 multiplied by 7a multiplied by 9b, and then plus this is 9b whole squared. This gives you 7 times 7 is 49. A multiplied by a is a squared. This is minus 2 times 7 is 14, and 14 times 9 is 9463 and 153, right? 214 9463, yep, this is 153, and this is a b, and 9 times 9 is 81. B multiplied by b is b squared. So this is your answer in this case. In the next video tutorials, we are going to discuss more and more problems, a lot of problems based on this standard identity only. So please keep watching.